Good morning to all. Myself Jayanthi. Today we are going to see about the topic types of linked list. In types of linked list, we have three types, that is singly linked list, doubly linked list, and circular linked list. In circular linked list, we have circular singly linked list and circular doubly linked list. In singly linked list, we have that in a node we have the two parts, that is data part and one is the address part. This address part stores that address of the next node, so it will be stored in that sequential order. Uh, in array, memory will be allocated if there is a contiguous memory is available. But in linked list, it is not essential to be memory in that contiguous location. So we can point to that next address by here. Here we are storing that address of the next node. That is, all nodes are linked together in some sequential manner with a single link field to point to that next node. Here it will point to that next node. In single linked list, we just store that address of the next node. But in doubly linked list, we have as in the single linked list, we have the data part and the next node address. In additional, we will store that address of the previous node. So here we require two pointer and one integer data type, that is which is used to store the data. So this is a doubly linked list. In circular linked list, that is same as singly linked list, but in the last, in singly linked list, here that value will be a 0 in singly linked list. But in circular linked list, here that last node address will be that first node address. So here we will store that address of the first node. So here there is a no start and that no end, so it will be in the circular manner. This is the implementation of a singly linked list. So here we have that list, that is here this is the address 100, 200, 300 and 400 are address. The data part is 10, 20, 30 and 40. These are the data. Here 200 is that address of the next node. That is 300 is that address of the next node and 400 is that address of the next node. So here at last we have that null value, that is it is that end of the list. Additionally, we have that one pointer, that is header start pointer, which is points that first node. Here that first node is, it is 100. So in that this in the start pointer we have that address as 100. So basic operations in singly linked list are creation, insertion, deletion, searching, traversing, and that counting that number of nodes. For dynamically, if we want to dynamically allocate that memory, means we use that malloc function, which is used to allocate that memory dynamically. So that here we have give that size of node. Here that is nothing but here is a data type. We are creating the node of by using that structure. We are allocating that memory space, so that here this is a structure name, that is the, suppose if I give size of int, means it will allocate the 2 or 4 bytes based on the compiler, it will allocate that memory. So here malloc is a function which is used to dynamically allocate that memory. Here we are giving that how much size to allocate. At last it will return that starting address. So address we can store in that using that pointer data type. So here we will store that starting address. In new node, it will point to that address, it will point to that memory. So if we want to allocate that memory, means we use malloc function. Suppose if we want to deallocate that memory, means we have to use that free function. So free function, it will deallocate that memory, so that memory can be used for that other resources. We have to check that is start is equal to null. Here we are checking that condition whether the list is empty or not. Suppose if the list is empty, means we can't able to delete or display that list. So for that we are checking this. Thank you.